Tampering with the card. Well, after we have recovered the keys and we understand the data format, tampering with the card, of course, is easy. We can do purchases on the tempered card to validate whether it really is an online or offline system. And possible manipulations are pretty obvious. We can decrease the value on the card, thus lose money. We can increase the amount of value on the card, gain money. And we can also bypass the daily spending limit by just resetting it so you can spend even more in a single day. We could also do things like recharge it to even more money than you can charge it to, but I think that would start to become suspicious. Or people would think you're like a government official, I don't know. Somebody who has extra privileges, no idea. Or whether the readers would actually accept it. So the first thing to do, of course, is decrease the value of the card. You make a purchase in a store, you find the transaction log entry, you retroactively increase the cost of the purchase. So you've purchased something for $100 NT, you increase it to 400, and then you decrement the value block storing the account balance, the card balance, by the same amount, and suddenly you have a card that's completely consistent with itself, but has less money. You also have to order the amount you've spent on that day, because suddenly you've spent more money on that day, to make sure everything again is in a consistent state. Now, let me just show you. I'm going to introduce that tool in a second. So I've written a program called Easy Tool. And I can do something like, well, post MRT entry. So what we get here is the unique identifier of the card. The day of manufacture of the card, we get the current account balance, $400 NT. This was when I started. No purchases today. I have entered the Liu Zhangli station, and I haven't left any station yet, because that was after entering the station with a newly purchased card. And you see the transaction log has, again, 2 copies of the same record. This is the date, timestamp, and so on, and the amount of dollar that's still remaining on the card. Now, after leaving, there was a different timestamp, of course. After leaving that very same station, the card looks a little bit different. Well, we only have 388 NT dollars left. We have left the same station at exactly 4 minutes after entering it. Well, you could have left something at home, and you need to, go back home and grab your laptop or something and go back. Transaction log. Also, if you're a foreigner, tourist, of course you get lost. You leave the same station again. You see the transaction ID gives you 1 is the first transaction and 2 is the second transaction. You will again see everything is copied twice. I didn't order it by date or transaction ID or something. It just dumps it in the order that's written on the card. So we have leave MRT, enter MRT, and so on. It has cost me 12 NT dollars, and 388 is remaining. And if I do the same with further, where is it? I actually went to Starbucks and had a coffee. I'm not a coffee drinker, so, well, anyway. So we have a shop purchase of 95 NT dollar, which is, I think, as much as a coffee frappuccino tall size is in Starbucks, Taiwan. And we have 293 NT dollars left on the card. So the format is very well understood at this point. We can decode everything. We can read the transaction log and so on. Now, manipulating, as I said, decreasing the value is the first attempt we can do. The other thing, of course, is, we can do it, and it has been done. Card behaved like expected. So it had less value remaining, not only in Easy Tool, but also when you go to the shop. It was still possible to use it anywhere, in shops and in public transportation. The artificially removed money could not be spent. So when the card reached 0, you could not spend any more money, meaning that the value stored on the card is really the value that the system respects, not some value in the backend. And the card could still be recharged at recharge machines. So even at the recharge machines, they didn't know what's the real value of the card, but they just read what's on the card and incremented it and write it back to the card. I would have expected at least a recharge machine to have some online connection and a shadow account in a database where you then can correct the offset, but that was not the case. By the way, this was my second attempt. The first attempt, the card actually failed. I couldn't buy what I wanted to buy. So I made some inconsistency in the data structure. But yeah, it was second attempt was then working. Now, the next thing, of course, you can do is increase the value on the card. It's not really that different, right? You find a transaction log and you decrease the cost of the previous purchase. So let's say you buy something for $300 NT and you suddenly retroactively make it cheaper to $100 NT, which gives you an extra 300. You increment the value block accordingly. You manipulate the amount spent per day in sector 15 to reflect the reduced amount, and suddenly you have more money on the card. It has been done. And the card behaved like expected. It had more value remaining. It was possible to use it in stores and public transport. And you could spend all the money to the last NT dollar, even the money that you didn't really have. Just the card said you have it. So once again, proof that it's an offline system. There's no online database check. And the card could again still be recharged at recharge machines without losing the artificially incremented added amount of money. So just as a note, the money that was artificially added was immediately really added to the card later and then manipulated back. So, right, there's no fraud involved in this. So what happened is the card didn't have money. It was artificially recharged. Something has been bought, just to prove the point. Then the card was actually recharged using the amount of money that was artificially added previously. And then it was manipulated to reduce that amount of money. So in the end, the balance was the same, and all the money that has been spent has actually been spent in cash. So there's no fraud involved in this. Okay, now, then there's this program EasyTool, as I already showed. It understands the format. It also has code for adding and like incrementing, decrementing the amount. It has not been released to anyone. And I'm thinking of releasing a read-only version where you can just, I mean, it doesn't crack any keys, it doesn't recover keys, it doesn't do anything cryptographically. Assuming you have the matching keys to a card, with the version I intend to release, you can read the stuff that I have been reading, but there's the manipulation code I do not intend to release publicly. So let me just go through some more examples. So if we go further in the history of this, what happened? So I went to another store and bought something, I think this is not a card that had been tampered with. Just to show you a card that has some more transactions, it just looked like this. So you see some different station names, some different values, some different amounts, different shop purchases. But I can show you the actual yeah, so this is a card that I had been used. So originally it was charged with 1,000 NT dollars. It had a value of 237 NT, and I just bought something. The last transaction identifier, C3 here, this is the last transaction. I bought something for 75 NT dollars, and I manipulated the card to increase the cost of the C3 transaction to $275, leaving only 37 NT dollars remaining. Right? This is the decrease part. So I increased the cost of the last purchase, and I decreased the total amount. And then, if we continue the log, there was some stuff, that it didn't work, but then. Yeah, this is after spending some additional, in a C4 transaction, spending some additional 20 NT dollars in bottled green tea at a convenience store. So from 37 NT dollars, we get reduced to 17 NT dollars. So this was the shop purchase. And after we look at the next transaction, we see stuff like, I'm trying to find the increased transaction here. Not quite sure whether it's in this log file, but it's pretty much the same thing. Yeah, this I think is a modification of 275. I have to check. Maybe it's a different card where I actually added some value, but I think you get the point. You get the point of this entire exercise. So, using a MyFair Classic or any RFID system based on proprietary security, that's based on security by obscurity, I think it's extremely irresponsible. And using a MyFair Classic-based public transport system, which may provide sufficient level of security for public transportation, using that in the year 2010 as a payment system is, I think, ignorant, clueless, and a sign of gross negligence by whoever is in charge of this. I think government regulators should mandate the use of independently audited and reviewed security technology. Security by obscurity is not an answer to any problem. Well, my thanks slide to the various people who have made this possible. As I said, I didn't do anything in this case, but actually look at text dumps and find out what it was. It actually reminded me a lot to something like, 16, 18, 20 years ago when I was modifying saved games on the PC or the C64, right? It's not really that different. You go into the game, you do something, you look at the hex dump and you see where is the value for the amount of credits I have or for the amount of whatever ammunition or God knows what it is. It's not really any different in this case. Adding the sort of 3-hour key cracking time for that. Okay, well, thank you for your attention. Happy to take questions.
Well, Harald, you're very ahead of time, so we've got lots of time for questions. Sorry?
EasyCard Corporation knows about these problems. In fact, years before they went live with the payment system, I mean, it was still used for public transportation only. Researchers from various Taiwanese universities have tried whatever they could, writing letters to the government and to the company and so on, warning them of doing this, but they still did it. And there's a group of researchers at National Taiwan University which have done similar modifications than I did. I only spoke about them after I did it. And they are using different sort of less effective attacks. So they have a USRP in a backpack, and it's sort of much more cumbersome. They don't do card-only attacks. They actually have to sniff the communication between the card and the reader in order to get the keys. So different attack vector, but they have done the same thing. They have added value to the card. And they have actually done it on their student ID cards, which also have EasyCard functionality, which are clearly tied to themselves. And they have done this a couple of, must be about a year ago now, and they've never been contacted. And there's never any inconsistency has showed up with that particular student or their card or something. Nothing happened. So they could very clearly know. And as I said, they've been warned by the local academia very, very strongly. And they still decided to deploy the system, which, well, I don't know how this comes, but it's not my business either.
Okay, if you've got questions, can you put your hand up, please, and we'll get a mic to you. Can I get one of the audio angels to hand up? He's gone, hasn't he? Oh, no, there you go. Okay, yep, you first.
Hi, I just wonder, other than RFID card you've played in Taiwan, have you ever come across a RFID system in mainland of China, say Shanghai or Beijing?
I've been to Shanghai and other places in mainland China. I think I actually have some of these cards, but I never really had time to look at it. As I said, I also have cards from Rio de Janeiro and Sao Paulo and other places wherever I go and use public transportation. But as I said, I never really had the intention or the time to look deeper into this. In Taiwan, this was just as I happened to be there that often, and all this work was done in 2 days, by the way. It was very, very quick. And very, very simple. But then I had a lot of existing experience with RFID systems. But still, it's really not a very, very difficult thing. I have no idea how other transportation systems work or what they use. I know in Japan they use a system called Felica, which is based on triple DES as far as I know. So the encryption is much stronger than MyFair Classic, but I don't know what's used in Shanghai or other Chinese cities. Sorry.
Yeah, because recently I just got this RFID card from Shanghai. The manufacturer claimed this is going to be their solution to replace the MyFair card, and they are using their own proprietary algorithm to protect. So I think if you got time, maybe this can be one of your next projects, or anyone here.
Yeah. I personally have to say I'm too busy. I have too many projects going on. This was just 2 days in Taiwan just for fun. Now, just one comment, you said, somebody's advertising, we have our own proprietary crypto to replace the other.